National Electrical Code (NEC) does not have a blanket requirement mandating 2 exits only based on a 1200 amp service. The NEC addresses exit requirements based on the occupancy classification and the specific use of the building, rather than the amperage of the electrical service. For example, the NEC mandates specific egress requirements for assembly occupancies, educational occupancies, and healthcare occupancies to facilitate safe and rapid evacuation during emergencies. The primary reason for requiring multiple exits in certain buildings is to ensure occupant safety. In the event of a fire, power outage, or other emergency situations, having multiple, well-defined exits provides alternative escape routes, significantly reducing the risk of occupants becoming trapped or injured. This redundancy in egress pathways is a fundamental principle of life safety in building design. When considering the electrical service for a building, it's crucial to understand the building's occupancy classification as defined by the building code, which is often based on the International Building Code (IB). The occupancy classification determines the specific requirements for exits, including the number, location, and capacity of exits, as well as the required fire resistance ratings of exit enclosures. While the NEC doesn't directly tie the number of exits to the amperage of the electrical service, it's essential to consider the potential impact of a failure in the electrical system. A fire originating from an electrical fault could obstruct a single exit, rendering it unusable. Therefore, providing multiple exits mitigates this risk. In designing an electrical system for a building, especially one with a high occupancy load or complex layout, it's prudent to conduct a thorough risk assessment. This assessment should consider potential hazards, including electrical fires, and evaluate the adequacy of the proposed egress strategy. Local building codes and authorities having jurisdiction (ODs) may have additional requirements or interpretations that go beyond the minimum requirements specified in the NEC. It's crucial to consult with the AHA during the design phase to ensure compliance with all applicable regulations. Furthermore, consider the layout and size of the building. In large buildings, especially those with multiple floors or complex floor plans, providing multiple exits strategically located throughout the building is essential to ensure that all occupants have reasonable access to a safe escape route. The NEC addresses emergency lighting requirements in Article 700.0, 701.0, and 702.0, which mandates the installation of emergency lighting systems that automatically activate upon failure of the normal power supply. These systems must provide sufficient illumination to allow occupants to safely evacuate the building. The NEC also addresses the installation of exit signs in Article 700.0. Exit signs must be clearly visible and properly illuminated to guide occupants to the exits. The selection and placement of exit signs must comply with the NEC and local building codes. In addition to the NEC, other codes and standards may apply to the design and installation of electrical systems and egress systems, including the International Building Code (IBC), a Life Safety Code (NFPA 101.0), and the Americans with Disabilities Act (ADA). It is important to be familiar with all applicable codes and standards to ensure compliance. The ADA requires that buildings be accessible to people with disabilities, including those who use wheelchairs or other mobility devices. This includes ensuring that exits are accessible and that there are accessible routes to the exits. Consider the potential for blocked exits due to storage equipment or other obstructions. Exits should be kept clear and unobstructed at all times. Regular inspections should be conducted to ensure that exits are not blocked and that exit signs and emergency lighting are functioning properly. Occupant training is also crucial. Building occupants should be trained on emergency evacuation procedures, including the location of exits and the use of fire alarms and other safety equipment. Regular fire drills should be conducted to familiarize occupants with the evacuation procedures. While the NEC does not explicitly require 2 exits for a 1200 amp service, the design of the electrical system must consider the overall safety of the building occupants. This includes considering the occupancy classification, the size and layout of the building, and the potential hazards that could affect egress. Consult with the AHA and other qualified professionals to ensure that the electrical system and egress system are designed and installed in accordance with all applicable codes and standards. The location of the electrical service equipment should also be considered in relation to the exits. The service equipment should be located in a secure area that is protected from unauthorized access and from potential damage. The service equipment should also be located in an area that is well ventilated to prevent overheating. Furthermore, consider the coordination of the electrical system with other building systems such as the fire alarm system, the sprinkler system, and the HVAC system. These systems should be designed to work together to protect the building occupants in the event of an emergency. The fire alarm system should be designed to automatically activate upon detection of a fire and to alert the building occupants to evacuate. The sprinkler system should be designed to suppress the fire and prevent it from spreading. The HVAC system should be designed to shut down in the event of a fire to prevent the spread of smoke and fumes. Ultimately, the decision of whether or not to provide 2 exits for a 1200 amp service depends on a variety of factors. It is important to carefully consider all of the relevant factors and to consult with qualified professionals to determine the best course of action. The NEC in section 110.26 addresses the working space about electrical equipment. This section specifies the minimum clearances required around electrical equipment to allow for safe operation and maintenance. These clearances must be maintained regardless of the amperage of the service. The NEC also addresses the protection of electrical equipment from physical damage in section 110.27. Electrical equipment must be protected from physical damage that could impair its operation or create a hazard. This protection may include enclosures, barriers, or other means. In addition to the NEC, the National Fire Protection Association (NFPA) publishes a number of standards that are relevant to the design and installation of electrical systems and egress systems. These standards include NFPA 70E, Standard for Electrical Safety in the Workplace, and NFPA 101, Life Safety Code. NFPA 70E provides guidance on electrical safety practices for workers who work on or near electrical equipment. NFPA 101 provides requirements for the design and construction of buildings to ensure the safety of occupants in the event of a fire or other emergency. It's crucial to understand the difference between a code and a standard. A code is a set of mandatory requirements that are adopted by a jurisdiction and have the force of law. A standard is a set of recommendations or guidelines that are developed by a standards-making organization. While standards are not mandatory unless adopted by a jurisdiction, they often represent best practices and can be used to demonstrate compliance with codes. When designing an electrical system, it's important to consider the potential for future expansion. The electrical system should be designed to accommodate future load growth without requiring major modifications or upgrades. This may involve oversizing the service equipment or providing additional conduit capacity. It's also important to consider the maintainability of the electrical system. The system should be designed to allow for easy access to components for maintenance and repairs. This may involve providing adequate working space around equipment and using readily available replacement parts. The NEC addresses grounding and bonding requirements in Article 250.0. Grounding and bonding are essential for electrical safety and help to prevent electric shock hazards. The grounding system provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and de-energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, which reduces the risk of electric shock. Surge protection is another important consideration for electrical systems. Surges can damage sensitive electronic equipment and can even cause fires. Surge protection devices, SPDs, should be installed to protect the electrical system from surges. The NEC addresses surge protection requirements in Article 280.0. The design of the electrical system should also consider energy efficiency. Energy-efficient lighting, motors, and other equipment can help to reduce energy consumption and save money. The NEC addresses energy efficiency requirements in Article 220.0. The NEC also addresses the installation of renewable energy systems such as solar photovoltaic, PV systems and wind turbines. These systems can provide a clean and sustainable source of energy. The NEC addresses renewable energy system requirements in Article 690.0 and 694.0. In summary, while the NEC does not explicitly require 2 exits for a 1200 amp service, the design of the electrical system must consider the overall safety of the building occupants, and egress is a crucial element of that safety. Factors such as occupancy classification, building size and layout, potential hazards, and applicable codes and standards must be taken into account. Consulting with qualified professionals and the AHUA is essential to ensure that the electrical system and egress system are designed and installed in accordance with all applicable requirements. Furthermore, remember to consider the working space around electrical equipment as per NEC 110.26, ensuring safe operation and maintenance, and to protect equipment from physical damage as outlined in NEC 110.27. The interplay of all these factors determines the appropriate egress strategy, and in some cases, multiple exits will be a necessary component of a safe and compliant electrical installation, regardless of the service amperage alone.